Hello dear student, welcome in our 11th lecture. Myself P.S.Patil. Student, in the previous lecture, we have seen that the gel permeation chromatography and affinity chromatography. These two terms we have already seen in the previous lecture. Now, in this lecture, we are going to discuss the gas chromatography and supercritical-fluid chromatography. In short, we called it as SFC chromatography. So the learning objectives of the today's lectures are: student must know the principle as well as working instrumentation application of this gas chromatography. Then after that, the supercritical fluid chromatography, its application, then principle, all these terms we must understand after the completion of this lecture. Okay, so let us start the first, that is gas chromatography. Gas chromatography is also sometimes known as a vapor phase chromatography, in short VPC chromatography, or gas liquid partition chromatography. Student, in the previous lecture, we have seen that in this chromatographic technique, there are two phases are used. One is mobile phase and another one is stationary phase. So, in this gas chromatography, the mobile phase used is a gas and the stationary phase which is used as a liquid. That's why the name is gas liquid partition chromatography. In short, we called it as GLPC. Okay. Then the next point, that is the definition of this gas chromatography. Gas chromatography is a common type of chromatography used in the analytical chemistry for separating and analyzing the compound that can be vaporized without decomposition. Student, if anyone asks you what is chromatography, what is gas chromatography, then you must told the definition of this gas chromatography. Here the definition is: it is a common type of chromatography used in the analytical chemistry for separating and analyzing compounds that can be vaporized without decomposition. So simply it is separation technique, as well as we find out the analyze the compound. Okay, then we see the principle. In the gas chromatography, the mobile phase, in another word this mobile phase, it is called moving phase, okay, is the carrier gas. Most commonly used carrier gas in about 90% of instrument, although the hydrogen is preferred for improve the separation. And the stationary phase is a microscopic layer of a liquid or polymer on an inert solid support inside a piece of a glass or a metal tubing called a column. That means, student, in from these two sentence, we conclude that the mobile phase used in the gas chromatography is a carrier gas, while the stationary phase used in this gas chromatography is the liquid or a polymer material. Okay. The instrument used to perform a gas chromatography, it is called a gas chromatograph. What is the name of that instrument? Gas chromatograph or aerograph or gas separator. Okay. Then we see the application of this gas chromatography. This GC is an instrumental technique used forensically in drug analysis, aerosol, toxicology analysis of other organic compounds. Okay. The GC is one of the popular instruments used in the world. Several advantages included. Means world several applications are there. Some of them are high-speed analysis in a matter of a minute and routine and less few analysis in a matter of a few seconds also possible, and we see also both rapid analysis as well as the high sensitivity analysis. For example, is this 2.5 minutes of separation three common pesticides like methyl, parathion, malathion and ethion at a Pg level, and Pg means 10 raised to minus 12 grams. These are the parts per billions. This is very good example of both the high speed as well as very sensitive detection. Okay. Then the another application of this gas chromatography are food and beverages application. Food and beverages contain numerous aromatic compounds, some naturally present in the few materials and some forming during the process, right? This GC is extensively used for the analysis of these compounds, which includes ester, fatty acid, alcohol, aldehydes, terpenes, etc. that can be detected by using this detected or separated from this GC technique. Okay. It is also used to detect and measure the contaminants from spoilage or adulteration which may be harmful and which is often controlled by governmental agencies, for example pesticides. Means food adulteration is day-to-day life is very serious issue, so that can be solved by using this gas chromatographic technique. Okay, so with this we complete the gas chromatographic technique. Student, you must understand the meaning, definition and the principle of this gas chromatography and applications of the gas chromatography. Okay, then we start the second, that is supercritical fluid chromatography. In short, we call it as SFC. So let us see the introduction about this SFC technique. Supercritical fluid chromatography can be used on an analytical scale. Means it is also used in the analytical chemistry. It is a common of high performance liquid chromatography. It is a combination of high performance liquid chromatography, in short called it as HPLC, and gas chromatography. That means this SFC, it is the combination of HPLC and GC. It can be used with non-volatile and thermally labile analytes. It can be used with the universal flame ionization detector. It is important to producing a narrower peaks due to the rapid diffusion. It is important for the chiral separation and analysis of high molecular weight hydrocarbons. Supercritical fluids are suitable as substitute for the organic solvent in a range of the industrial and laboratory process. Okay, so student, you have to remember from this point slide, it is the combination of HPLC and GC technique. Then it is used with the non-volatile and thermally labile analytes. Whatever the matter we are going to separate, it must be non-volatile and thermally labile. Then it can be used universal flame ionization detector. Means in the instrument of this SFC, we use the flame ionization detector. Okay, the important, it shows the narrower peak due to the rapid diffusion. Whatever peaks are obtained at the last, it is narrower. Okay, so this is the introduction. Then we see the history of this SFC. Use of supercritical fluid chromatography was first proposed in 1958 by J. Lovelock. First reported use was in 1962 by P.S.Patil, who separated thermally labile profilings. Definition of this SFC, it is a combination of high performance liquid chromatography and gas chromatography. A supercritical fluid chromatography is a material that can be either liquid or gas used in the state above the critical temperature or a critical pressure where gases and liquid can coexist is known as a supercritical fluid chromatography. So this is the definition. What is that? It is a material that can be either liquid or gas used in the state above its critical temperature or a critical pressure. Means the material which we have to be separated, that is it may be liquid or gas, and its state of that liquid, it is above its critical temperature and critical pressure, and where the gas and liquids are coexist. Such a material can be separated by this supercritical fluid chromatography. Then the principle of this SFC, it is a combination of GC and SPLC. The principle, it is based on the adsorption and partition chromatography. Okay, the principle based on the triple point and critical point, and the principle, it is based on the supercritical fluid. Okay, so you have to remember the definition, principle and history of this SFC. Then next, the important terminology which is used in the SFC technique. In that we use critical temperature word. What is that critical temperature? It is the constant temperature. In the definition, we have seen that the liquid or gas which is used in the above critical temperature and critical pressure. So means constant temperature. Critical pressure means constant pressure. Okay. SFC temperature, for every substance there is a temperature above which it can no longer exist as a liquid no matter how much pressure is applied. SFC pressure, for every substance there is a pressure above which it can no longer to coexist as a liquid no matter how high temperature is raised. Okay, so these are the terminology used in the SFC. Then we see the instrumentation of this supercritical fluid chromatography. In that, the term instruments used are mobile phase, stationary phase, pump, injection system, oven, column and detector. Here the flame ionization detectors are used. Okay, so these are the instrumentation for the SFC. We only list the instruments name here. Then next is mobile phase. There are a number of possible fluid which may be used in SFC. As the mobile phase, mostly CO is used, carbon monoxide. The main disadvantage of this carbon dioxide, CO2. Here CO2 is there. CO2 is used. The main disadvantage of this carbon dioxide is its inability to elute very polar or ionic compounds. This can be overcome by adding a small portion of a second fluid called a modifier fluid, that is alcohol or the cyclic ethers, acetonitrile and chloroform. The addition of the modifier fluid improve the solvating ability of the supercritical fluid and sometimes enhance the selectivity of the separation. Means here the mobile phase it is used is CO2, and the disadvantage of this of CO2 is the inability to elute very polar and ionic compound. Okay, then the stationary phase, same as those for GC and LC with some modification. Silica and alumina is used, which is useful for non-polar compounds. lead to the reversible adsorption of some polar solutes. Other SFC solvent, nitrous oxide, similar in solvating and separation properties to the CO2, but inexpensive. It's expensive. Okay. Alkanes less safe and not as a detector compatibility than the CO2, better solvent characteristics for the non-polar solute. So this is the instrumentation part. Then the last point is advantages of the SFC. Supercritical fluid chromatography has several main advantages over other conventional chromatographic technique like GC and HPLC. Compared with the HPLC, SFC provides a rapid separation without the use of organic solvent with a desired environmentally conscious technology. The use of organic chemicals as used in the HPLC could be reduced with the use of SFC. Means in HPLC, organic chemicals are used that can be reduced in this SFC. Because SFC it is generally used carbon dioxide collected as a byproduct of the other chemical reaction or is collected directly from the atmosphere. It contributes no new chemicals to the environment. In addition, SFC separation can be done faster than HPLC separation because the diffusion of the solute in a superfluid is about 10 times greater than that in a liquid and about 3 times less than in a gas. This results in a decrease in resistance to the mass transfer in the column and allow for fast high resolution separation. Means this SFC it is superior than HPLC because in HPLC organic solvents are used that can be reduced in SFC. During that the main use of CO2 and this CO2 it is collected as a byproduct from many other reaction as well as it is directly collected from the atmosphere. That's why it is a superior than the HPLC and its time it is 10 times greater than the HPLC. That's why it is a superior than HPLC. Compared with the GC, capillary SFC can provide high resolution chromatography at much lower temperature. This allows a fast analysis of thermomobile compounds. Finally, this SFC have the advantage of higher diffusion constant and lower viscosity relative to the liquid solvent. The low viscosity means that the pressure drops across the column for a given flow rate is directly. Okay, this diffusibility means longer column length can be used and higher diffusion coefficient means higher analysis speed that increase in the order of HPLC, SFC and JC. These advantages are important in both chromatography and extraction with the SFC. Then the application of these SFCs are SFC finds the use in industry primarily for the separation of a chiral molecules. Chiral means what? All the vacancies are occupied by the different group that is called the chiral. Suppose we take the carbon atom and the carbon atom has a 4 valency. So all these 4 bonds means all these 4 atoms are different. That's why that carbon it is called the chiral carbon. So the such a chiral molecules can be separated by using this technique. Use the same column as a standard HPLC system. This SFC is now commonly used for the achiral separation and purification in the pharmaceutical industry. Means achiral separation is also done by using this technique. Fossil fuel and hydrocarbons are also separated by using this technique. Polymers are separated by using this technique. Drugs and pharmaceuticals, other compounds are also separated by using this technique. Explosive and propellant are also separated. Lipids and carbohydrates are also separated and detected by using this SFC technique. So student, you have to remember this technique. Main, you have to remember the definition of this SFC. Then after that, principle of the SFC and the application of SFC. At the FY level, you must know these three things: definition, principle, and application. And you must know the history, who was invented by this technique and at which year it was invented. That you must know at the FY level. Okay. So in the next lecture, we discuss the remaining point, that is capillary electrophoresis and HPLC, that we will discuss in the next lecture. Okay. Thank you, student.